Hi, this is King of Review. Is there an intersection between y equals x plus 5 and x squared plus y squared equals 4? One way to solve this problem is to use substitution to find the points of intersection. And if there are points of intersection, then you know that the answer would be yes to this question. So let's use substitution here. We have the equation y equals x plus 5. We're going to substitute the x plus 5 into the second equation for y right here. So we have x squared plus y squared equals 4. Notice I left an open space for y. I'm going to substitute x plus 5 for y here. So x plus 5 goes in the parenthesis. Now let's expand this portion. X squared plus x plus 5 times x plus 5 equals 4. Now I have x squared plus, and I'll use FOIL to multiply this out, x squared plus 5x plus 5x plus 25 equals 4. Now combine like terms. I have 2x squared plus 10x plus 25 equals 4. I want to get a 0 on one side of the equation, so let's subtract a 4 on both sides. I have 2x squared plus 10x plus 21 equals 0. Now this equation is in the form ax squared plus bx plus c equals 0. When we have an equation in this form, we can use the quadratic equation to solve for x. The quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac, and this is all divided by 2a. The a, b, and c values come from these numbers here. So on our equation, a equals 2, b equals 10, and c equals 21. Let's apply these values to the quadratic equation. X equals negative 10 plus or minus the square root of 10 squared minus 4 times 2 times 21. And this is all divided by 2 times 2. When we simplify, we get negative 10 plus or minus the square root of a negative 68, and this is all divided by 4. What do you notice about this number here? We have a negative number under a square root sign. This is not a real number. When you have a negative number under a square root sign, this is not a real number, so it does not exist. So this means that there are no points of intersection between these two graphs. So letter B is correct. You could also solve this problem by graphing. You could graph each of these equations on your graphing calculator and see if they intersect or not. I'm going to do a rough plot of them now so we can see what this situation looks like. So our first equation is y equals x plus 5. We know that this is a line because it's in slope-intercept form. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So in this case, this graph crosses over the y-axis at 5, and it has a slope of 1. So let's do a rough sketch of that. Here's our x-axis and our y-axis. Okay, so it crosses over the y-axis at 5, which is right here, and it has a slope of 1. So that's up 1 over 1. So that's right here. So we can use these 2 points to do a rough drawing of the line. Okay, so here's our line. And now let's look at the second equation. The second equation is x squared plus y squared equals 4. We know that this is a circle because it's in the form x squared plus y squared equals r squared. We know that the circle here has its center at the origin, which is right here, and we know that r squared equals 4, so the radius is 2. So if we were to plot this circle, it would pass through these points because it has a radius of 2. So I'm just roughly filling in what this circle looks like. And here's our circle in red, our line is in black, and you can see that they do not intersect. There is no point where they touch. So there are multiple ways to solve this problem. You can choose algebraically or by graphing. Thanks for watching.